A very good afternoon to all of you, and welcome back for the post-lunch session of this workshop. So, seems many of you are on time, so we can soon start the session. But before starting the session, let's have a small poll based on our understanding. So far you have used the Maestro visualizer for doing various tasks, basically for analyzing the protein, analyzing the ligand, sketching the ligand molecule. So let's have a small poll. So here you go. The poll is in front of you. Please try to answer the simple two questions, and then we will have short discussion on it. Thank you. Yep. Thank you very much for participating in the poll. So here I just end the poll and then see the results. And I hope at the end of discussion you will have a little bit more information on it. So the first question in the poll was what is the price for Maestro interface? So most of you have correctly answered it as a free. So basically Maestro is the interface which comes free for academic use. So you can straight away go to Schrodinger website and download the Maestro interface. It's free. But the for doing task we need various modules, and for those modules we need to pay. But as such, if you want to use the Maestro interface for any type of visualization purpose, it's free. And then second question was how do you rate handling of Maestro on the scale of 1 to 5, easy to difficult? So I mean, it is expected that most of you have answered it as it is maybe easy or maybe difficult, and that's perfectly fine. So it's a good distribution, but at the end of day, I hope everybody will like it, and then you will feel like it is easy to use Maestro. So it's about any software. It's all about using. As much as you use the software, as much as you get a hold on mouse, you will feel it easy to use. So this is what the Maestro you have. So thank you very much for answering the poll questions. So I here just stop sharing the results. And I feel that most of you have already joined. Maybe we can wait for 1 more minute and then we'll just start it, because we need to cover many topics, and for that it is not good if we simply getting it delayed. So before starting the next session, if you have any questions related to the previous sessions, if you feel to discuss, I think this is the time, and we will have short discussion on it. So please feel free to unmute yourself and ask your question. So there is a question about hands-on practice on QSAR and homology modeling. So that's not covered in this particular workshop, but if you are interested in doing that, please come back to us. You have my email ID. You can come back to us, and then I will let you know it in detail, so you can use it further. Thank you. Yes, for keyboard shortcuts for rotation, you can simply use dot button on your keyboard. So just give a try pressing dot button, full stop button on the keyboard, and it will rotate the molecule on screen. Yes, so thank you very much again. So it seems like you have no more questions. So we can swipe up and down trackpad to zoom in and zoom out. So you can do that, but it's a little bit tricky. So just explore the options which are shown in view button, and you'll be able to do that. Thank you. So let me first share the screen, and then we will start the next session. So here you go. Yeah. So I hope the screen is visible to all of you. And so far you have explored various aspects of visualization and visualization of small molecule, visualization of the protein structure, and you saw how to draw the structure in 2D, how to draw the structure in 3D, how to modify the ligand molecules, small molecules, how one can get the small molecule structure using smiles format or any different type of format. So these are all things which we have seen so far. So it helps you to get familiarized with the Maestro interface. And onwards, we are actually going towards using the same task to do the structure-based virtual screening or the process of molecular docking. So let's start doing the task now. So again, doing molecular docking means finding interaction between protein and ligand. Though it looks like a single step, but it's not a single step. There are few more steps which you need to follow it in a background. And what are those steps? So those steps are like to perform molecular docking, as explained by Dr. Pritesh in the presentation, you need to have a biomacromolecule. That's your protein structure. So you can have the protein structure from protein data bank or any type of other database, and that you can use it for the molecular docking. The same way you have a receptor, like protein is called as receptor, and then you have a small molecule. Small molecule is just like a paracetamol structure which you have drawn. The same way you will have a lot of different small molecules which acts as a drug molecule, and those you can use it for the process of molecular docking. So the idea is you have a structure of protein which acts as a receptor, and then you have a structure of small molecules which you are using it for the molecular docking inside the binding pocket. And when we say binding pocket, it means you need to define that binding pocket inside the protein structure. So let me show you a little bit in detail. So you can see here the structure of protein is in front of you, and it's shown in the surface view as mentioned by Dr. Kaushik in the presentation. And you can see the always structure of protein is very much uneven in shape. So there are many small sub pockets which can accommodate a ligand molecule inside it, or your ligand molecule can fit anywhere on the surface of protein because there are many spaces available. But the beauty of protein structure is ligand molecule doesn't go anywhere inside the protein structure. It has a particular space where it goes and where it fits stably, like that, like what existing structure we have here in the green color. So it means ligand doesn't go anywhere in the protein structure, it just go into the specific binding pocket. And this particular binding pocket is your active site. We call it as an active site inside the protein structure. So same way, every protein has definite binding pocket. We need to identify that binding pocket, and then we need to specify that binding pocket in terms of protein. So it means the first step, you need to have a protein structure. In second step, you need to prepare that protein structure. And in third step, you need to define the binding pocket. In fourth step, you need to get the structure of small molecules with you separately. And in fifth step, you need to prepare that small molecule structures. Once you get the prepared structure of protein and the small molecules, then in next step, you can perform molecular docking of it, and then you can perform analysis of it. So these are the few steps which we are going to follow it in coming sessions. So right now, let's start with the first step, which is a protein structure. So for that protein structure, we are going to use a protein structure of one of the kinase protein. Its PDB ID is 6B2Q. So the same protein structure, I'm just importing it again from the protein data bank. For that, you can directly go to file and get PDB. So in get PDB, you just need to correctly type the PDB ID of your interest, which is 6B2Q, and the chain A, let's say. So this is what the PDB ID of our interest. So please do not try to remember this name because it is all mentioned in the handouts correctly. So if you read the handouts correctly, you will find that it is already given there. So you just need to type it correctly, 6B2Q chain A, and hit the download button. And once you hit the download button, it will load the protein structure for you on the screen. So it means you have used the same protein structure I am talking about. This is what we are going to use it for the process of molecular docking for today's exercise. So inside this particular protein structure, if you see carefully, this is the crystal structure of protein, and it doesn't have information of hydrogen molecule, hydrogen atoms. There might be many problems which come up with the protein structure. So it is very often, it is very general that protein structure which you get it from protein data bank, that has lot of issues, lot of problems, as mentioned by Dr. Pritesh in the presentation. And as a molecular modeling scientist, it is our duty to resolve all those problems in the protein structure to get the well-refined protein structure as a output. Once you get that well-defined protein structure as a output, we can proceed further for the actual molecular modeling studies on that protein. So the first task, whenever you have protein structure available with you, we need to prepare that protein structure, and this is what exactly we are now doing, preparation of protein structure. So to prepare the protein structure, there are many problems associated with it, and to get rid of all those problems, we have protein preparation workflow. So that option you can find it here on the top left. Again, don't try to remember the options where it is and all. It is all mentioned in the handout which I am going to share with you. So you just need to click on this protein preparation button which is in front of you. Once you click on it, it will open a straightforward panel for you, and that straightforward panel is called as protein preparation workflow, rightly said on the name of this panel. So basically this workflow is for preparation of protein. So as I said, protein comes with the many problems, and in stepwise manner you need to solve all those problems one by one. So because you need to solve it one by one, so it might take time, or it might you need to go through each step one by one, and maybe you will feel hassle, okay, if I go through that step what will happen and all. So to make these things easy, Schrodinger has prepared one easy to use panel for you, and that is called as protein preparation workflow, and through which, using just single click, it will go through all those options and it will prepare the protein structure completely. So always remember, there are a lot of problems come with the protein structure, and you need to solve it stepwise one by one. But Schrodinger gives you easy to use panel. In just single click, it will prepare the protein structure completely. So how to proceed through it is, once you open the panel, Very first thing, you just need to go to substructure. In substructure tab, you will see there is an option to load workspace entry. So this load workspace entry means once you click on this load workspace entry, it will analyze the protein structure. It will tell you what are the components which are present in your protein structure. So you can see there is one component which is called as chain A, and it is for protein. So once you click on it, it is interactive in nature. It just select the complete protein structure for you. The same way you have other components. And what are those? So you can have ligand molecule. So here on the top you can see there is ligand molecule chain and its name. So there is one ligand molecule which is called as CJJ. So this is what our actual inhibitor molecule which is present inside the protein structure. And this is what the same ligand molecule which I have shown you before in surface view. So this is what the active molecule and inhibitor present inside the protein binding pocket. Similarly, you have some other molecule which is called as 0BD, and it looks like some glucose type of molecule which comes up with the protein structure when experimentalists wanted to solve the protein structure using X-ray crystallography. So experimentalists need to add various chemicals in the protein solution so that it gets crystallized faster. So such a molecule often come up with the protein structure. So we need to delete that molecule. So when I say such molecule often come up with the protein structure, so how do you know like this is extra molecule which you need to delete, or whether this is the inhibitor molecule which you need to keep? So for that, you need to read the paper. So in the protein data bank, wherever you find this crystal structure, you will have the link for paper, associated paper for it. If you read that paper, then you will easily come to know that which molecule is important, which molecule is not important. So for that, like the simple thing is just select your molecule which you wanted to get rid of, and then there is a delete button at the bottom. You can see here there is a delete entry. So just select your OBD molecule and click on delete entry. It will remove that particular molecule from workspace. Now your complete workspace left with the protein and the active molecule. This is what we need at this particular point. And that's it. Once you deleted that one, now you are ready to go with this particular protein structure. Now simply go to your protein preparation workflow tab, and where you have all the by default option which are working very fine for you. So you can just rely on all those options, and that's it. You are ready to hit the run button. So at the bottom right you will find the run button. So but before hitting run button, always remember one thing. So do not hit simply run button, just there is a bar wheel which is just present beside the run. This is called as settings. So this option you always need to remember onwards for the complete day. So just go to this settings, then you will find the option called job setting. Just click on this job setting option carefully. And what you need to remember is there is an option called host. So host is by default it is local host. You need to change it to CPU 240. And why you need to change this host from local host to CPU 240 is local host means the uh, mm, current workstation which you have. So there are 8 CPUs which are present in your current workstation, but this 8 is for all of you. So if all of you like 50-60 people submit job on 8 CPU, it will take a lot of time. So to make this process easier, we have deployed lot of computational power on cloud. And this cloud infrastructure is called as CPU. And there are 240 number of CPUs which are present on the cloud. So if you choose this particular CPU 240 option, then it will simply submit your calculations on the cloud infrastructure. And because of that cloud infrastructure, your job will get very faster completed. So this is what, do not forget to use this option. Host, change your host from local host to CPU 240. This is what is very much important to do. Please always use CPU 240 as an option. And that's it. Once you choose that particular option, then you are ready to go for run button. Just single click on run button, and then it will go through all the options which are necessary for any protein to get refined. So it will submit your job on the cloud, and then it will run through all those options one by one, and in stepwise manner it will prepare the complete protein structure in just single click. And let's see, you can see once this wheel started rotating, it means you have submitted your job and it is running. You can see here small wheel which is rotating. If you want to see like whether job is really running, what is the status of job, you can simply click on this running wheel, and then you will see here there is a job and its status. So it is not yet updated, but once you see in the job list, you will see the status of this particular job. It is running, the progress is running. It means job is running in background. And whenever you see like job is running in background, it means you really don't need to worry about it. It will run and it will finish the job and show you the output. So that's the only thing which you need to do. But again, remember, you just need to do single click on run button. That's it. Do not click it multiple time. Otherwise, what will happen? Multiple number of jobs will get submitted. Once you click on run button, be patient. Like it will take some time, but your job will be submitted uh, on the cloud infrastructure. So don't worry about it. Just a single click. Do not click it multiple times. So till the job is running, you can also monitor the status of your job in this job monitor button. You can see this job monitor button on the top right. There is ECG like button. If you simply click on it, it will show you the job name. Its name is auto prep, means auto protein preparation, and its status is running. So let it run. Once the job get completed, it will show you the option, the status is completed or finished. So once it happens, we will see the final results. In meantime, till the job is running, I'll try to show you which are the various options software look for to refine the protein structure. So these options are like, you have always settings button here in blue color. So if you go to this general setting, you can see it prepares the protein structure at particular pH condition, which is 7.4 pH condition. So if you know like which pH condition you should have, you can change this number. Otherwise, normally your protein is existing in the particular pH condition, and you can consider it as a neutral pH condition. Then it will automatically detect the ligand molecule, it will automatically detect the metals, solvents, and all other things. So it will go through all those options one by one and prepare it. Similarly, there are other options which you will find it in more option, like it assigns the proper bond orders. And bond order means, so software will understand whether it is single bond, whether it is double bond, whether it is triple bond. So all that information which is normally missing in the protein structure, because experimentalists, when experimentalists resolve the structure using X-ray crystallography, it doesn't have any valence information. So that is the reason why software needs to identify it correctly. Similar way, it adds the hydrogen molecule inside the protein structure which were not there in the protein structure from X-ray crystallography. In this way, it may add the missing atoms, missing loop. Those are normally missing in the protein structure. So software needs to add it correctly. Then software also need to do the hydrogen bonding assignment correctly. So hydrogen bonding is the one internal hydrogen bonding inside the protein structure is responsible for maintaining the protein structure integrity. Just like explained by Dr. Pritesh in the presentation, that software that you have a primary sequence, secondary structure, and tertiary structure of the protein, and that tertiary structure can be maintained by hydrogen bonding interaction that needs to be access correctly and do it correctly. So this is what software does. And in final cleanup step, like it will perform energy minimization of the structure correctly. So these are the various options which one need to go through stepwise manner. So you use any software, but these options one need to go through carefully every time. So for that reason, software Schrodinger has created this panel in which you really don't need to worry about. Just open the panel and hit run button, and that's it. Software will take care of everything. And you can see the beauty of Maestro is whenever job get completed, so it will automatically load the output results into the table. So here you can see the output result called auto prep, and it has given the entry name called 6B2Q prepared. So means it has prepared the protein structure correctly. Everything is correct. You can rely on the data, and onwards, once you see this prepared structure correctly, then you can use this prepared structure for further molecular docking studies. So this is the only task which you need to do at this point. As such, straight away you just need to import your protein structure 6b2q, and that's it. You just need to go to protein preparation workflow panel, go to substructure, load the workspace entry, analyze workspace, delete this OBD ligand. From here, delete entry, and then go to protein preparation workflow, and you just need to go to settings, change your local host to CPU 240, and that's it. And now you can ready to hit the run button. So it all things are pretty straightforward, just few clicks away. And the handouts which I am going to share with you will help you to go through all those options and prepare the protein structure. So this is what the thing which you need to do at this point. So I just stop sharing here, and then I'm just going to share with you the handouts for the same task, which is called as protein preparation wizard for the um, protein structure. So please check the Zoom chat box. Handout link is given. Please do go through the handout and do not skip any step. It's pretty straightforward, few clicks. And let us know if you have any question related to that. So I'm just opening breakout rooms for all of you. So Kaushik, could
Prajwal,
you please
just before you start, like make sure that all of you submit the calculation on CPU. Don't run it on localhost. That will hang the whole cloud instances for all of you. So please run it on CPU as mentioned in the handout. Three of us, Prajwal.
Okay, thank you very much. Yeah, rightly pointed out. Again, make sure you do not submit job on localhost. Try to follow the handouts correctly. Thank you. So here you go. The rooms are open for all of you. Please do join the breakout room and try to interact with the scientists present in your room in case of any queries. Thank you. Yep, welcome back, all of you. And I hope you are able to follow the handouts correctly and able to submit the job. So maybe for some of you, the job is running, or maybe for some of you, the job got completed for the protein preparation. So no need to worry. If job is running, let it run. It will finish soon. But now at this point, like we can proceed further for the next step. And as I told you that for doing molecular docking, we need to follow few steps. So first step is already done. So you have the protein structure from protein data bank. You prepared that protein structure using protein preparation workflow. So once the protein structure is prepared, now it's time to define the binding pocket. So to define the binding pocket, this process is called as receptor grid generation. So that's very common name which you come across with any molecular docking process, receptor grid generation. So this grid generation is nothing but the specifying binding pocket for the protein structure. And now question comes, how to specify the binding pocket. So first thing is, your protein structure has ligand inside it, and that ligand is the inhibitor molecule for the protein structure. And this information you get it from the paper which is present for this particular protein structure. So you just need to read that paper to get the idea of it. So once you come to know, okay, there is a ligand molecule, inhibitor molecule present inside the protein structure. So straight away, we are going to use that information for defining the binding pocket for this particular protein. So for this, the first thing you need to do is make sure you have the prepared protein loaded on the screen. So when I say loaded on the screen, it means the blue circle should be on in front of that entry. So which means the entry is present on the screen itself. So now it's time to highlight that ligand molecule. Here in the 2D overlay, you can see there is a 2D structure of ligand. So this is the same ligand which is shown here in green color in 3D. The same ligand is shown here in the 2D. So it means ligand is present inside the protein structure. So our task is to highlight that ligand molecule right in front of you on the screen. So to highlight that particular ligand, we have a ready to use button, and that button is called as preset button. So you just need to go to this preset button right in front of you, top middle on the screen. You can see preset button. So simply click on this preset button, and here there is the first option, apply custom preset. Again, don't try to remember the steps, it is all given in the handouts. So just go to preset button and apply custom preset. And once you single click on it, you will see right in front of you, the ligand is highlighted in front of you in the gray carbon in the 3D ball stick view, and all the protein amino acid residues are shown here in lines view and a cartoon representation. But at this point here, the point of our interest is the ligand molecule and its structure right in front of you. So this is how one can highlight this ligand molecule straight away in front of you. Once you have highlighted that ligand molecule, it is now in front of you. So next thing is look for the option. So to look for the option, here there is a task button. Straight away in front of you on the top right, exactly on the top right, if you see, there is a small task button, extreme right. Okay, so if you go to this task button, you will find the option called browse. So this was the few options which were shown by Dr. Kaushik before. So if you simply move your mouse on browse button, you will see a lot of different modules and options present in the Schrodinger suite. So basically, Schrodinger suite is a complete package which has hundreds of tools to do the molecular modeling and computer aided drug designing studies. So all those tools are already present there, out of which you need to look for the specific tool of our interest at this point. So that tool is called as glide. So you click on the browse button, and in lot of applications on left hand side you see the glide option again. So this glide option, if you click on it, the first option you will find here is the receptor grid generation. So this is the option which I was talking about. Receptor grid generation means define the binding pocket for the protein structure. So simply click on receptor grid generation option, It will open again straightforward panel for you. So this is what the straightforward panel which you have. It has lot of options, but you really don't need to worry about all those options because all those options by default works very fine. So you can rely on all those options. So once the panel is open in front of you, what you need to do is you just need to carefully look on the screen, move your mouse on the ligand atoms which is highlighted here right in front of you. So all those ligand which is shown here in ball stick view gray carbon, you just need to carefully move your mouse on ligand atoms and click on the any atom of the ligand which you feel correctly. So when I say any atom means it is literally any atom. You can click on the any single atom of the ligand, but only thing make sure you do the single click on the ligand atom. It should not be on the protein atom or anywhere else. Just make sure your mouse is exactly at the any atom on the ligand and just do single click, just single left click on your mouse. That's it. Once you do it correctly, just single click, you will see the complete ligand is selected in the green color boxes. It means the task is done. So it means you have specified your ligand molecule as a center of grid, and that's it. This is what our task is done. Now we have provided the option to software. Now it's time to hit the run button. But again, I am specifying one more thing. So before hitting run button, always you need to remember, just go to this bar wheel besides the run button, and this is applicable to all of the task onward. Every time before hitting run button, just go to this bar wheel beside that, change your host from local host to CPU 240. This is what the important thing which you need to do and you need to remember. This is what is also mentioned in the handout. So read it carefully. So please change your local host from local host to CPU 240. This is what the important thing which you need to again understand. And once you do it, that's it. You are ready to hit the run button. Just simply hit the run button. And then you will see at the bottom it is saying submitting job. So it submits the job. Soon it will start running, and then once it start running, you can monitor this job by seeing, like now you can see the job started and the wheel started rotating. So wheel started rotating, it means the job is running. Again, remember, do not hit run button multiple times, just single click and wait. And if you want to see the status of job, you can always click on this rotating wheel and the job list, and then you will see what is the status of job. And you can see right now it is running. The same way, you can also monitor the job using this ECG button, which is called a job button on the top right. Just click on it and you will see that the job status of glide grid running. And you can see now it just took like less than a minute to get completed. Once the job get completed, it will automatically save the file inside your working directory. That file we will use it for the further molecular docking process. So this is what the only task which you need to do at this point. So if you have any question, please let us know. And here it seems, just check the Zoom chat box. I have shared with you the link for handouts. So go to the handout, try to follow the handouts. It's just a single click, easy, straightforward way to do it. And then once it is done, we will proceed further for the next step. So for that, I'm just creating breakout rooms. So here you go. The breakout rooms are open for all of you. Please do join the breakout room and try to interact with scientists if you have any queries. Thank you. So thank you for joining again. I hope the grid generation you are able to submit it right correctly. So if it is running for you, let it run. No worries. So for somebody says glide running failed. So what is meant by glide running failed? So you can show it in a breakout session. We will try to help you out. What is the problem? Maybe you did not follow the handouts correctly. Just I request you to follow it correctly or raise your query in the breakout session. We'll help you out. So at this point, we can proceed for the next step. And for that, I like to invite my colleague Vinod to help us with the further next step.
A
Thank you.
very good afternoon to everyone. Thank you, Prajwal. Hope I'm audible.
Yes, perfectly fine.
Hello.
Yeah, perfectly
Prajwal.
fine.
Okay, so let me just try to share my screen and then get started. I hope you can see the my workstation. Is it
Uh, yeah,
instance clear?
yeah, it's clear.
Okay, great. Okay, so I think right from morning we had a very nice presentation on drug discovery and how in preclinical studies computational chemistry tools are useful. So in that aspect, if you notice, we started with preparing with 6B2Q, our target of interest, and we prepared it. And our objective is to dock against this target some series of synthetically valid molecules, and we'll see like how good are those for further studies. So there will be a qualitative justification and quantitative justification behind selecting and rejecting that molecule. But before getting into ligands, so it's important that what are the different resources of ligands you can get. So quickly, I'll just give a brief on some of the databases which will be quite handy to have them. There are two kinds of databases. One is kind of label data, which is very famous is drug bank. If you go to sorry, I have typed it data bank. Okay. So not only those who are totally new in drug bank, you will be able to understand the overall studies that are performed to achieve the excellence of drugability for a therapeutic cause. This is a nice database to look out for. Please go through your target of interest into this and see what kind of studies are carried out before proceeding for your research work. The other databases, which is pretty famous, is PubChem, which has labeled data, unlabeled data. It's a big repository of database for any references and programming programmers. The API is also available for fetching up information on similar ligands also. And but some of the databases have unlabeled data. These are the molecules whose biological activity has not been tested out. So, for example, like Asinex is a database which is especially good for biologists who don't want to synthesize molecules and want to purchase it directly. These are already available molecule has been synthesized and characterized. These molecules you can download and use it in the computational approaches and purchase this molecule as you do it in Amazon and Flipkart. Another database which is similar to unlabeled database is
Yeah, I think it got stuck. We'll just give him some time for him to reconnect again.
Hello, Prajwal, can you hear me? I'm sorry, I think I had a small
Yeah,
glitch.
now I can.
Hello.
Yeah, yeah,
Okay,
now we
thank
can
you.
hear.
I'm really sorry for that. Okay, so let me just refresh the logins and I shall share my screen now. So I was talking about different databases. I hope until then it was clear. Is it fine, or do you want me to repeat something? Prajwal, could you please just
Yeah, I
confirm me?
think databases was clear. We can proceed.
Okay. So I'm going to share the screen now. Let me just try to share my screen after Asinex. Okay, great. Asinex, I was talking about a database called as Enamine. Okay, so Enamine is you can just check it out. It's a good database that you can search on. So similar databases are available, but for our demo reasons, we have handpicked some set of molecules. I'll be sharing you the path of the file also, so don't worry about it. I hope you can see my screen, and I'm gonna browse the set of molecule that we will be working on. So throughout the workshop, we have all the input and output files placed in the desktop data folder. So anybody I have seen like my job has not run and all that, all the files are inside this MTB workshop files, which has input and output files for all the requirements. For example, this is a prepared protein. If you have missed on protein preparation, this is the input for ligands that we will be using, and this is in smiles format. So it's a collection of molecule. I will open it and I will show you them like as how it looks like. So you can see it's a collection of maybe tentatively around 36 molecules that are present, and all are in its in 2D format. So as it was already explained well by Dr. Kaushik, you can see all these structures are in 2D format. So it's very much required that they are prepared for its 3D geometry optimized. And also, we should take care of the stereoisomers, ionization parameters, and the stereochemistry. And all that can be easily handled by using a simple tool called as LigPrep. So I will search for, like you can see in browse, there is a handy tool here, LigPrep. At one stretch, it is going to make sure that it prepares all your molecules, like 36 molecules at one go. So if I use a workspace option, then you will end up preparing only one molecule. But we need to prepare all the 36 molecules, so we'll use this. It also has options for filtering out based upon filter criteria. This is not required, but for those who are very keen on molecular weight and number of atoms and all that, you can add the filters with higher than, lesser than, and you will have your specific library of your interest. And it has a threshold of 500 atoms. So if in case your molecule is having more number of atoms, then LigPrep is not a tool to use. The ionization, as you can see, it is currently in neutralized state, but you can use generate all state if you are not aware of your pH of your work. So this is something called as biological pH. The range is between 5 to 9. As you can see, it is set to 7 to plus or minus 2. And if you are not, if you are like very sure that okay, it is at this specific pH of range, then you can change it. Otherwise, it's good to go with neutralize option. And here is an option. You can see there is an option for generate tautomers. Generate tautomers, tautomeric states are case specific to molecules. I don't suggest that until unless you have requirements. And desalt uh, it's going to remove any salt form in the like retaining. For example, if you have diclofenac sodium, the sodium is the smaller component and the diclofenac is the your molecule component, so it will be desalted automatically. Stereoisomers, I request you have to use the option retain specified chiralities, or you should use determined chiralities from 3D structure. And please don't create any combinations. I mostly suggest to retain it as one per ligand, because usually stereochemistry separations are very difficult to handle, and in the later stages, if you want to do wet lab studies, it becomes very, very difficult. So it is very, very important that we strategize our whole process in a way that the research doesn't ends up only in silico. It should end up in experimental outcomes. So here the lick prep option is here given, and I can go for job settings and make sure you use CPU option, which where you have tons of like 240 processors. You can use 16 processors for the time being, and luckily I think we have less number of participants now, so you can launch it. And I have launched this job, so it's pretty handy and easy to do these steps. It's going to take some time, but in the meantime, because I showed you, right, the output files are already been placed, so we can go and take and check out on those structures. So this is the lick prep output file which generates. So here is my set of 36 outputs that has been prepared, and you can easily see the difference between the 2D structure and 3D structure. So that's what I thought to share it for the time being. But I'll be happy to take any further questions. I'm going to share the path of the input file and the handout with all of you. Please let me know if any of you have any questions, and I'll be happy to help you out. Thank you, Prajwal. But I have additionally given the input path also.
Yep. Thank you very much, Vinod. So, participants, please check the Zoom chat box
Yeah,
and
I just
go
got
through
a
the
question.
handouts.
Is it converting 2D to 3D? Yes, absolutely. It's converting using force field OPLS 4. There is OPLS 2005 also. This force field has understanding parameters of what bond angle, torsions it has to take. So I hope, Neelkant, that's a nice question. Yes, LickPrep does the conversion of 2D to 3D. Thank you, Prajwal.
Yeah. So please check the Zoom chat box and go through the handouts. Try to do the ligand preparation as rightly shown in the handouts. And for that, breakout rooms are open. Please do join the breakout rooms and let us know if you have any difficulty. So thank you.
Dear participants, welcome back. I hope most of your calculations were successfully launched for preparing your structures, and hope you would have also analyzed the difference between a 2D structure and a 3D structure. So now I'll continue my discussion for showing you a demo as how to launch the docking. So docking is one among approach that can help us to shortlist the molecule as which is the good molecule or bad molecule. The objective of the overall workshop is to understand and qualitatively and quantitatively justify as from this 36 molecule which is the best molecule that you can consider for experimental works. Actually, it's a collection of derivatives. And once the lick prep is over, you can see all the structures as an output. So this is a 2D input which I gave, and once it is prepared, you get a 3D output structure. I think for docking, it's very simple. You need to only remember three things: what to dock, where to dock, and how to dock. So these questions you need to ask, and let me give you the answers. The answer is simple. The ligand output is the answer for output of what to dock, and where to dock is the grid file, not on the protein. The protein is prepared. You remember Prajwal has done a grid generation, right? So the grid output is the answer where to dock, and how to dock is the algorithm that we will be using. Now, going further, as I said, the objective, as I clearly said, we need to understand as which molecule is the best. And for that, we are using molecular docking as one among the approach. There are different kinds of other approaches for rank ordering the molecule, but docking is the best in structure-based drug design. Now, as I said, the first question is the receptor grid is nothing but the where to dock question, right? You click browse, and if you have followed the instruction, then you will see in your working directory itself the glide grid underscore one.zip file will be there. And if you have not followed, you missed out, go to desktop, and in the desktop data folder, we have this mtb, and here also we have the zip file, glide grid file. So this is the answer for where to dock. Okay, now what to dock? I think I told you already that output of the lick prep should be used, so that I can use it from the project table like this directly, or I can browse it as a file also. In the same working directory, you will find the lick prep out file which you can use. So that path also is there in the demo folder. In case you are not able to prepare your lick prep output, then I will give you the path. You can use that also. For the time being, I'm using project table selected entries, which has a collection of 36 molecule to be docked. And there are different docking modes, like high throughput virtual screening mode. There is standard precision mode and extra precision mode. I think in the introduction, it was clearly mentioned in docking, the first approach is the conformational search and then the scoring matrix. So if you notice, the scoring matrix stays the same, but the sampling, the conformation sampling varies. For HTVS, it is less, and standard precision, it is medium, and extra precision, it has additional conformational scoring scope. So that is the reason extra precision takes the longest time and standard precision takes an average time. So for the demo reasons, we will use the standard precision approach. The ligand sampling will be flexible for those who are worried about the various conformations. So it will be sampled by Schrodinger by the glide algorithm. So if you see, it generates close to 5,000 poses, retains around a scoring window for 100 kcal per mole, and 400 poses are processed, and energy window is kept 2.5 kilocal per mole. So don't worry about that. You don't have to do any special minimization for that. So that is the reason ligand lick prep does a basic minimization. And like in case if you're interested in using your own conformation and then do it, you can use a rigid approach. which will going to score all your conformers that you have generated from your own algorithm. Now that's all. I think this is the major things that we need to remember. Other than that, you have to just go to job setting, give a prefix of the job. Like for example, this is 6B2Q, and you know that it's best to go with CPU. And the number of processes I can mention like 8 or 16. Like I'm just gonna mention 16 so the job get finished faster. And I keep it by default. Okay, so if you run, that should be great. And that's all for your docking launches. I think I will call upon for a breakout, and then once we come back, then I'll be showing you as how to do the analysis qualitatively and quantitatively. The docking submission, yes, thank you, Prajwal, and I will share the input files also in case some of you are not able to get the files. So let me just share that. Here is the path of them, the ligand output that you need to use for your docking, and also the glide grid that you can use. But in case if you have done it, you should find it in your working directory. So Prajwal, then we can have a short breakout, and then we can meet. And thank you. Dear participants, welcome back. I hope all of your calculations are launched and running, and some of you are lucky enough to get the output also. So now it's the excellent time to do the analysis and decide as which molecule is the best. So I'm going to share my screen and then explain you the logics of selecting a molecule. So personally speaking, so selecting a molecule is always like selecting a match in a marriage. I think you can imagine like you can't just be too biased on the qualitative appearance or quantitative outputs that is being shown. So it's very difficult to just pre-decide on just basically a single parameter like docking score. So if you notice the once the output has been come, you can see here there is a small bar and you just click on view poses, and this will set you up in a way that you can visualize all the poses. I'm going to explain you one by one as how to see them and how to decide which molecule has better affinity. Here the major role is played by the native molecule. The native molecule is the bound molecule that we have used during our protein preparation. So if you notice here, I can show you that. So this is the native molecule that is already present here. And while doing post visualization, remove this auto setup, because auto is going to like just pre-fit your overall view, and it's gonna get little messy. So I just want to focus only the bound ligand. I hope you can see here. You load the protein, and the first entry is actually a blank protein. So here it is. You can see this is the native protein, and whenever you do selection, the world is very mean and very relative. So it's very very important that you compare with the native molecule and take your call. So there is nothing called as good docking score and bad docking score. One among the very critical parameters for a better binding is the non-bonding interactions. So if you notice here, so this is the native non-bonding interactions that are present. I can count it like 1, 2, 3, 4, and 5. 5 interactions are available. Now imagine hypothetically, so the molecule that may possess similar kind of interactions may be the best molecule to proceed further. So that's a hypothesis I can consider. So this is the molecule, native bound molecule, and I'm gonna remove this chain, and we will focus now, just gonna load it one by one, and we'll focus C here. So this is a molecule, actually this is a native molecule which I already placed, and you will notice that it has excellent reproducible interactions maybe, and in similar manner you can compare all the other poses and decide which molecule has the best non-bonding capability. If you feel that 3D interaction is quite messy and it's not liked by you, then I would request you to go with ligand interaction diagram. So here also you'll be able to load one by one molecules, but make sure you change the poses, that is as output, because in docking you get only the top best pose. I know some of the students and researchers are quite curious about exploring all the poses. In ligand docking output, when you're launching your docking, there you can increase the poses. But I'm not a big fan of, because see, imagine now if you have each molecule 10 poses, then 36 molecule will end up in 360 poses. So I'm not trying to be biased on selecting my best interaction. Actually, I'm trying to find out the molecule that can give me the top interactions. So the most promising ones will be in the top pose. So that is the reason I went for top one pose. So like this is a qualitative way of visualizing, and similar view, like if you are like a researcher who feels no, I'm not curious about the interactions, I'm curious about the position of the pocket where it binds, that matters a lot. So in that case, let me just try to clear the workspace. So here I have cleared it, and you can load the protein and generate a molecular surface of the protein. So here is the protein, the full view of your protein. Let me just show it to you. And yeah. So you need to generate a molecular surface for this protein, and how can you do that is just select the complete protein, and after selecting the complete protein in the style, you can go for surface. Now visual inspection selection is very interesting skill to have, but when you try to compare it relatively, it's much easier to do that. So I have just added it. I hope it should be visible. Let me just see. It's taking time. I don't know, like. So you could overlap. So here is a surface. It's a nice view. You can just load the molecule one by one. You can fix the molecule pose like this. Just double click on that and you can load it one by one. Now it may feel like very small again. Just click L and you can zoom into your ligand. So here is the view. This in a way that so that everybody can see. I am sorry for that. Okay. So this seems to be a nice view. I hope I can see the surface of the pocket and try to compare it with all the other ligands that are present, as how the orientation and what is the coverage of the pocket it holds. So if you are curious to find a fragment that should specifically fit to specific pockets of interest for specific biological cascade mechanisms, then you could select. For example, like if I'm focusing on this pocket, it's just an example. Okay, don't take it too seriously. So if I need some fragments, then I would be curious and focus on the interactions also and the fragments that are cleanly shown in this part. So this is another way. But in case you want to summarize the overall interactions of non-bonding interactions in a single nice plot, then search for shift, SIFT, SIFT interaction fingerprints. And here you can see there is an option of generate fingerprints. And once you, oh, I'm sorry. Okay. Hold on. So make sure for that you should select the full group. If you don't select the full group, then you will get an error like what I got. And here you go. So I have done it now. At one go, it is going to give me the complete interactions patterns in a matrix, and also you can export it as a interaction counts into project table or file. So this is a nice illustration, as you can see that all the respective residues and what are the common interactions that are frequently occurring in the series of 36 molecules that I have launched, and what is their count of residues, as which residues is playing major roles, and also which ligand is much having stronger interactions. So that is also present. So this is a nice plot. And this can also be fragmented into backbone interactions if you're interested with that, or polar residues, or if you're interested with hydrogen bond donor. So all those explanations are given. So it's up to you to responsibly evaluate all this. So this is all qualitative measures. So where are the scores? So the scores are there in the project table. So the project table scoring parameters, the very famously known as the docking score, is there. And as I said, I always compare that with the native molecule, and there are a lot of properties to explore. So what you could do is just select, and then you can say hide, so that all the properties are hidden, right? And then you can focus on the property of your interest. Like for example, if I'm interested with only glide, then I can activate only glide, and primary I can show only that. So you can see this is the docking score and this is the range of the docking score. So don't, it's not like our university ranking. So don't get happy that if you got too much good score means it's a great molecule. it's always a guess, like, okay, this could be the best one, because always not the top university toppers always be very successful, because it's up to the individual as how they decide as what skill set they want to focus and to leave it in similar manner. Any small molecule can be effective, so there is a range that you need to target. So I need to compare that with a native molecule. So actually I think I have a native molecule which has a score of minus 10.616. Then at the end of the day, maybe you may have some molecule above and below. So for thing, if I'm in your case, I can select any molecule that has a more than score of minus 10 is promising. I'll evaluate its interaction pattern and also the position of the pocket, and then decide. And if anybody is curious on, okay, adding more complexity to this, you can add like van der Waals energy parameters, E model parameters, or you have lipophilic interactions. So in the secondary parameters, you have all those parameters. So there is not a single rule by which you can select or reject your molecule. It's a combination of rules. As I said, it's like selecting a match or the marriage. And at the end of the day, here the molecule can be successful or unsuccessful, and the cost has to be bared by the company or the company owner who has trusted on you. So take a proper call and then decide on your best molecule to proceed further. So I think that's all what I plan for analysis and molecular docking, but I'll be happy to take any questions.
Yep. So there seems to be one question, little bit interesting. So can these data be used for pharmacophore generation?
Thank you, Prajwal. Yes, pharmacophore generation the poses, but don't generate pharmacophore from a in silico docked pose. Any drug discovery approach has to start with experimental and end with experimental. That's the philosophy I have. So in this case, if you are interested with pharmacophore, then you need to generate a pharmacophore for the co-crystal ligand X-ray crystallographic structures. For the docked post, you have a lot of uncertainties, but still there are students who use it. So I will not inhibit you, but I will suggest that use it with caution.
Yep. Thanks a
Any other
lot.
questions from
So
anybody?
yeah, so there are no questions. So participants, please check the chat box. I have shared with you the link for docking analysis. So go to the handouts and try to do the docking analysis and let us know if you have any questions. So the rooms are
I
open for
think
you. Please do join the breakout rooms. Yeah, Vinod.
no, Prajwal, I felt because okay, number is 50, right? Okay, I thought we can manage in single room. Okay, thank you.
So welcome back, dear participants. So we are almost at the end of this today's session, which we have planned. And before ending the session, I request you to please check the Zoom chat box and please give your valuable feedback. It will help us to modify our workshop to make it more efficient. So it is always appreciable if you provide your feedback to us. So thanks for that. And we will have a short talk by our business development officer, Ms. Shelvia Malik, and she will tell you like how to access the software for free of cost. And there is a way to do that one. So she will tell you all the aspects of software purchase as well as software accessibility and what are the other things which come across. So please stay tuned. So yep. So I guess she has already joined. So yeah, over to you, Ms. Shelvia. Thank you.
Thank you. Can you all hear me?
Yes.
Yes, hi. So I'm not sure if I'm already introduced because I think I joined a little late. So I'll just introduce myself quickly. I'm Shelvia and I'm the account manager for most of the academic institutions and universities in India. And I hope you are enjoying our workshop and you are interested in using our software for your research. If you are interested to get a trial license or an evaluation license, you can contact me. I'll be sharing my email and my phone number in the chat. Before that, I also like to show you our website and some of the resources that are available for you. So I'm just sharing my screen. Please let me know if you can see it.
Yes, it's visible.
Yes, thank you. So when you go to our website, this is our home page. What I like you to do is please register on our website so you can just go to sign in. There's a small form that asks you about your, I can just show you. So when you click on register now, this page opens and there's a small form that you need to fill. Once you fill this, you need to submit the form. It takes about 48 hours for your the website account to get activated. So once the website account is activated, you can access a lot of resources that are available online on our website. So when you go to this learn on top, this you will also see this on your home page as well. When you click on this, a drop down menu will come. Here you can actually go by area, like today you discuss about small molecule drug discovery suite, you discuss about docking, so that will come under here. If you're interested in biologics, you can go to this page, and for material science, this one. We also have Schrodinger online courses, which I like to show you. So for now, we have 4 courses. Most of them are starting in Feb. So if you're interested in any of these courses, please let me know. You can write to me or you can call me, and I will help you out with a discount coupon. Some of the courses are introductory. So I saw in the poll in the morning that a lot of you are freshers. So I think one of these courses, the introductory courses, these 3 ones could be beneficial for you. You can click on this button to see exactly what you'll be learning. And to register, you can just click on this. So make sure that you have your website account active, because you do need to sign in order to register for in these courses. Once you sign in, you can see the schedule. There's one coming up in Feb, and then the whole schedule for the year is given here. This is, as you can see, it is not a free course, it is charged. And why it is charged is because we give you access to our software similar to the cloud instances you were using today. The same way you will get access to our software for about 5 weeks. Okay, and this is an additional cost for us. We have to install a software on Amazon cloud or the Google cloud, and we need to pay them. So for have that those costs, and also the cost for hosting this course and other things we need to pay. So it is a little expensive, but for you, because you were part of our workshop, I will be able to give you some discount. So this will be much lesser. So if you're interested, you can let me know if you are interested in this type of course. Even in biologic design, I think that could also be good for you. The one part that I really like about these courses, so I also took one of these courses, and the thing that I liked about it is that I was able to use the Schrodinger without having to have a big machine. And also you can access to all the tools that are available. The course doesn't restrict you to try and use any other module that you might be interested in, that might not be in your course syllabus. You can go explore the entire software. And also the tutorials that are given are much beneficial. They have a flow, like it starts with introductory of the modules, how you will use it, and then in the end there is a case study. There are also assignments, so you can evaluate like how much you understand about the subject. These are all these assignments that you actually submit during these the assignments will be actually graded. You will get a score, and you will have a personal feedback from one of our scientists all over the world. So these are also flexible interactive sort of learning, so you need not work during the day, during your college hours. You can actually do it at night, in the evenings, whenever you feel like. So there's no restriction. You can work during weekends. You can also write to our help team, who will be able to assist you if you're stuck somewhere. They are available. They are supposed to reply to you within 5 minutes. So like there are a lot of different advantages. Like you will also be using the industrial tools. So some of the commercial tools that are never sort of given to academics, you will be able to use that and have a hands-on experience on that. So I think these are some of the really exciting things that we offer. We also have a ton of free resources also, if you're interested in learning. And you can obviously write to us. Please make sure when you write to us that you CC your guide, because we need to know that you have your guide's permission when you're contacting us, and we'll be able to help you with even licenses, like trial licenses, and we can also train you if you're interested. So if you have any question regarding this, I'll be happy to take that. I'll also be sharing my email and my phone number, so do not hesitate. You can contact me anytime. I mean, office hours, preferably. All right. Thank you then. I leave it to you. I'll also see the chat if there is any question for me. Yes, we do have group discounts actually. So the group discount is anyway there on our website, even if you want to register directly. But if you like just write to me, I will be able to get you much more discount. So of course there is group discount. If you want to go individually, also there's a discount. But obviously, if you have a group of people, there'll be I will be able to get you more discount. So are there any other questions?
Yep. Thanks a lot, Shelvia. So seems there are no more questions in the chat box. So yeah, thank you again for sharing your contact details. So please
Thank
reach
you.
out to Shelvia in case of any software related purchase related queries or about Schrodinger online course. And please check the chat box. I have shared with you the email IDs for all of the scientists. In case of any scientific or technical queries, please feel free to reach out to us at any given point. We will be always there to help you out. And in meantime, please feel free to give your feedback through the Google form. The link is shared in the handout in the chat box. So please do provide your feedback. So with this, we are almost at the end of this workshop, and I hope you got some initial idea about the software and about the process of molecular docking. So again, as rightly pointed out, Schrodinger's is a complete package. It has hundreds of tools, and it is not even possible to get through all the tools by single person. So, but it is perfectly possible if you do it task by task, just like today we did it for molecular docking. Same way you can do it for pharmacophore mapping or for other tasks. So it is perfectly feasible. We can have discussion on it. So please feel free to reach out to us if you are interested in doing that. We will always help you out. And I think this is the time. If you have any question related to the task which we have performed so far, so you can unmute yourself and ask your question. And at this point, we can have short discussion on it. So please feel free to unmute yourself. Thank you.
Excuse me, sir.
Yes.
The feedback form, you've given two links, both are the same form, right?
Yes, both are same form.
Yeah. Thank you.
Okay, so if there are no questions, then we can conclude here the workshop. I would like to hand over session to the Genesys coordinator. If you are online, could you please comment? So there is a query called how to repair a protein structure. So I think you are talking about preparing the protein structure or repairing the protein structure. It's the same. You can go to protein preparation wizard as rightly we did, and it will prepare the protein structure correctly. Okay, so is there any coordinator from Genesys? Okay,
yes,
so
sir, just a second.
yeah,
One
yeah.
second.
Hi, Purushottam. Yeah.
Yeah, yes, sir, we are here.
Okay, that's great. Yep. So before that, I would like to make one announcement. So handout links are already with you. So in any case, like if and the cloud recording is also there with us, we are going to share it with the coordinator of this workshop from Genesys. And in case if you need it for future reference, please contact them. They will provide you the handout links as well as the cloud recording link. So please get in touch with them for further queries. Thank you. And over to you, Shaurath and Purushottam.
Yes. Sir, first of all, thank you very much for the workshop. To be very honest, I enjoyed it right from the starting, and I didn't miss even a single part. And even I missed, I was following the handout, and I think every other participant who have enjoyed like me as well. So, thank you so much for that. And we have also shared the feedback form among our participant and club members, so they will fill it as well. And I think then, sir, we can conclude this workshop.
Yes, exactly. Okay, then thank you very much for joining it, and I hope to see you in case if you have any queries. So thanks again, and I hope to visit sometime in NIT Rourkela once the COVID situation get improved.
Yes, sir, we would love to have you to the campus if we go to the campus as well.
Yes, thank you very much again.
Thank you, sir. We hope we can conduct more such sessions in future with Genesys and Schrodinger. It was really great having you. Thank you. Thank you to the
Sure.
whole team of Schrodinger from the whole team of Genesys.
Yeah, thank you very much.
Yes, sir.
Thank you, sir. And thanks everyone for joining. We'll conclude the workshop here. But do join us from tomorrow for the other webinars and paper poster presentations.
Okay. Have a nice day ahead. Bye.
Thank you, sir.